If you were floating in space, no one would be able to hear you whisper, talk, or even scream in horror at seeing a giant asteroid coming towards you. It's not only that you'd be far away from Earth, but sound needs space to travel through. Sounds are just vibrations of molecules and atoms in some medium, like water or air. Your body will pick up sound waves through the ear canal and to the eardrum. Vibrations we receive then transform into electrical signals so our brain can understand and recognize them. Frequencies of sounds humans can hear are between 20 to 20,000 hertz. Sound travels 4 times faster in water because molecules are closer together than in air. Naturally, it travels faster through steel than both water and air. The loudest natural sound on our planet is one made by an erupting volcano. Not 100% certain, but scientists believe the eruption of Krakatoa in 1983 was probably the loudest sound humankind ever had the chance to hear. It exploded with enormous force, destroyed its island, and released 20 million tons of sulfur into the atmosphere. People even heard it 3,000 miles away. It would be like someone producing a sound in New York and people hearing it all the way in Ireland. Sound can take many forms, but humans are most familiar with it in the form of pressure waves that move through the air. Sound goes more slowly through heavy gases and colder air. It travels faster through lighter gases, for example, helium. There's no water or air in space, so the sound doesn't have anything to travel through. Our atmosphere consists of 10 trillion atoms, which is like dense soup creating a way for sound to travel. And there are only 10 atoms per cubic meter up in space. That means space is empty and silent. But it wasn't always like that. The universe is 10 to 20 billion years old. It appeared as a result of the Big Bang. It wasn't an explosion that started from just one single point, but rather space appearing everywhere in the universe at the same time. Back then, the whole universe was like a hot ball of plasma. It was much thicker than today, so the sound could pass through it. As the universe was forming, it produced shock waves, and they, in return, produced a cosmic rumble, way deeper than things our ears can normally detect. These are the actual and the first sounds the universe ever produced, at the stage when it was still forming. Scientists decoded them and pitched them up to a version we can actually hear. As time went by, the universe was stretching. Today, it's a lot wider, emptier, and quieter. It's good for us, though. If sound traveled through space with ease, we would constantly hear loud explosions, crackles, moans, and other sounds space bodies make out there. The sun isn't silent either. Here's the sound of its vibrations created by its loops, waves, eruptions, and other activity. The sun creates trillions and trillions of watts of sound energy, something like pulsation, low heartbeat. It helps researchers discover what's going on inside of the sun and understand its layers. If it wasn't muted for us on Earth by a lack of air in space, it would be like hearing a jackhammer all the time. If you and your friend were taking a walk on the surface of the moon, you wouldn't be able to hear each other talk. No air, no sound. But that doesn't mean the moon itself doesn't produce any sound. When the first spacecraft landed on the moon, it caused crashes which later led to moonquakes. Scientists took a chance to measure vibrations going through the moon to figure out its internal structure. They realized they caused vibrations that lasted longer than they expected, and longer than any similar vibrations on Earth. It was like those moonquakes were producing the sound of a ringing bell. When we have earthquakes, moisture in the ground acts like a sponge. It absorbs the energy of the waves spreading around until it ends their effects, which is why water eventually stops the earthquake. The moon is dry, more like a solid rock. Moonquakes are less intense, but there's no water to stop them, so vibrations just go back and forth through the moon. The solid rock stops them at some point, which is when the ringing stops too. Let's see what happens with the sound on different planets. Neptune, Uranus, and Saturn are mostly made of helium and hydrogen. These gases are way lighter than the atmosphere on our planet, so your voice there would generally come out in a higher pitch. But each planet has its layers that make differences in sound. Neptune has its murky depths, Uranus its methane clouds, but they're both freezing, made of gas, and have ice particles in their atmosphere. Saturn, also a gas giant, boasts wild, raging storms. Saturn's biggest moon, Titan, is the only one known for having a real atmosphere. It's thicker than the one we have on Earth. It's very cold there, and it rains liquid methane. In 2005, researchers sent the Huygens spacecraft that managed to record incredible audio you might find familiar. The sound of winds, but billions of miles away from us, on Titan itself. If you were there, you might even hear the sound that reminds you of a waterfall. In reality, it's flowing liquid methane. Moving to Jupiter, it doesn't have a solid surface either. It's made of gas that becomes denser the deeper you go. At some point, it even turns into a liquid. The sound is different in each of those layers. Jupiter is actually pretty noisy and has bizarre sounds. It creates intense radio storms with powerful lightning bolts. While there, you'd hear their echoes of echoes, just going back and forth. Mars, its atmosphere is way thinner than Earth's, which means there are not many molecules for sound to travel. Winds can get pretty fast, like our hurricanes, but on Mars, they would feel like a gentle breeze. You wouldn't necessarily hear the storm though. You'd maybe hear the dust as it gets picked up and banged against your spacesuit. In the thin atmosphere, your voice would be much quieter, and it wouldn't travel far. Someone could be standing next to you and screaming, and you'd probably hear nothing. Low-density air actually makes our voices sound higher-pitched, but the cold temperatures, like on Mars, slow down the sound so it would balance out again. Your voice there would sound a bit distant and blurry. And imagine listening to an instrument like a guitar or piano there, like some muffled melody from a dream. Sound on Venus is kind of the opposite of Mars. Venus has a dense atmosphere, much denser than ours, something between water and air. There, you'd hear sounds like when you're underwater. The environment is a bit different with 900 degrees Fahrenheit and 100 tons of atmospheric pressure. But let's say you have a magical spacesuit that protects you from getting crushed or scorched. While on Venus, you'd hear thunder. 40 years ago, a spacecraft successfully landed on its surface and managed to go almost an hour before it shut down. It picked up these amazing sounds of strong winds. If you started talking on Venus,
your voice would first hit the lower pitch because of the dense atmosphere.
But it would then sound higher because hot air increases the speed of sound. It would be kinda distorted and muffled together with the sounds of thunder around you. Mercury is a rocky body with no atmosphere, so standing on its surface and talking would be like trying to talk while floating in space. Useless. Those are almost vacuum conditions, which would make you think Mercury has no sounds at all. Still, you can hear them, though not in the air. The rocks. Put your ear against the ground. Maybe a Mercury quake is coming. The universe is a place connected by light. Light can go anywhere from any spot in space, but not the sound. So not only do we have a planet that supports life, but offers a wide palette of sounds. Even without us, it wouldn't be a quiet spot. A light breeze gently caressing treetops, earthquakes, volcanoes, deserts. The ocean with its waves on the surface and scary sounds deep below. Up there, it's a quiet mystery. But down here, it's true magic.
In space, no one can hear you scream. Or is that, in space, no one can hear ice cream? Well, either way, we know that no supernovas, crashing asteroids, and burning planets make a sound in space. Or do they? What if you actually can hear something out there? Well, let's see. Okie dokie, back to middle school. Sound is a mechanical wave originating from vibration. What exactly does that mean? Well, the simplest example is guitar strings. Let's pluck one of them. It starts to vibrate. The atoms inside the metal string begin to push and beat the atoms of the air around them. So now, atoms are constantly pushing each other until they reach our ears. It's like a wave from a pebble thrown into a pond, and it happens very quickly, at a speed of about 761 miles per hour. Then our eardrums begin to vibrate at the same frequency, and the little bones inside our ears transmit this vibration to the brain. The brain then does its magic, recognizes the pattern, and turns it into sounds. Great! Now we know that we need some particles to create sound, and we can find these particles in gases, liquids, and solid substances. And what about space? Nope, it's almost a perfect vacuum. And you've probably already heard that there's no sound in space because it's a vacuum. But what does it actually mean? Well, a vacuum is a perfect void. It's an area completely devoid of matter. It means there's nothing there. Yeah. Despite all those celestial bodies in space, there's actually no air in between them. No atoms, no particles, nothing, nada, zippo. Well, almost. To be honest, the perfect vacuum doesn't really exist. We can't get rid of atoms for good. But space is very close to this notion. On average, there are 15 to 80 atoms per 1 cubic inch. This may sound like a big number, but keep in mind that these atoms are tiny, and the void distance between them is huge. For comparison, 1 cubic inch of air contains about 16,000 atoms. So, of course, with such a low density, these atoms can't push each other. Even if the vibration is very strong, like, I don't know, a supernova, they still won't be able to do that. So, movies have been lying to us. All these epic space scenes actually take place in an awkward silence. Who would have guessed? But don't get upset. What if I tell you there are, in fact, some ways to hear sound in space? First of all, there's still sound on other planets. If there's an atmosphere on a space body, or at least something like gas, water, or a solid surface, there will be sound. In our case, the atmosphere becomes completely silent at about 60 miles above the Earth's surface. That's where the sky stops being blue and a black starry veil begins. In any case, we'd have to land on another planet, or at least get close to its atmosphere to hear something. But whatever it is, it would sound very different. Let's take our favorite Venus as an example. The atmosphere there is very dense. Scientists jokingly call it a thick chemical soup. No thanks. So, if you somehow managed to stay alive and speak there, your voice would be very different. It would become much louder, and it would sound deeper. So, if you want a pleasant baritone, you know what to do. I wonder what would happen if Earth had a denser atmosphere. What would we hear then? Well, you can vaguely imagine that if you've ever been in the water. Water is very dense. Sound moves there much faster and better compared to the air, at a speed of almost a mile per second, depending on the water temperature. So if you sit in an empty room with no sound sources, you won't hear much, right? Now, dip your head in the water and check out how the same silence sounds here. It's not quiet at all. Even if you ignore the ever-present sounds of the water itself, you'll immediately notice how well you can hear your own body, how your blood pulsates in the veins, how your heart works, the slightest movement of your fingers. Kinda creepy, isn't it? This gives us an idea of what would happen to us on a planet with a denser atmosphere. And that's just crazy. We would hear everything. From scurrying animals to the movement of tectonic plates. Come on, you'd probably say. It's obvious that there's sound on other planets. But didn't you say we can hear something in open space? Actually, yes. For example, in a cloud of dust. You can find space dust almost everywhere in space. It may be the remains of a star or something else. And in these places, everything is a bit denser than usual. This means there are probably dust clouds where particles are very close to each other, which means they can produce sounds. Of course, those will be very quiet and transmitted over a very short distance. But it's better than nothing, right? Plus, we already have one real space sound recorded. It came from the Perseus galaxy, which is located 250 million light-years away from us. NASA recorded it in 2003. Those of us music geeks will want to know that it's a B flat, 57 octaves below middle C on the piano. You'd have to add another 660 keys to the left on the keyboard. But its frequency is so low that the human ear unfortunately can't hear it. But besides that, we can only hear something inside spaceships. These are small pockets of air, after all. In a spacesuit, you would hear sounds very well too, including your breathing or blood circulation in a spacesuit. But two astronauts flying side by side wouldn't hear each other, even if they got very close and shouted very loudly. It's quite funny. If you, being an astronaut, bumped into something, it would be very loud for you, but your friend wouldn't hear anything. That's why astronauts use radio devices.
291, cancel your call, 2879 will handle.
Now, purely theoretically, if you could somehow crawl out of your spacesuit and survive, you'd be able to hear the chatter and noises going on inside the spaceship. But how? So look, we have some air inside the spaceship and it transmits sound. It reaches the metal casing and gets through it. And then, if you leaned against the ship, preferably touching it with your elbow or knee, the sound would be transmitted to the brain directly through your bones, ignoring the ears. Yes, our bones conduct sound. That's how, for example, deaf people listen to music. It's called bone conduction. It's used in some headphones and some other technologies. You can do a little experiment. Hold your fingers over your ears. Shut them properly so that you really don't hear much. Then try to touch a sound source. It can be anything vibrating. For example, a speaker playing music with some part of your body where the bone is close to the skin. Now, watch the miracle happen. You can hear the sound not through your ears, but directly in your brain. But please, don't repeat this experiment in open space. Ice cream? Haha. Now, you've probably heard about things like the sounds of space, where you can listen, for example, to the sounds made by the sun or different planets. How do we record these ones? Easily. There is another way to hear sound in space: electromagnetic waves. In other words, a radio. Radio is the same form of electromagnetic radiation as light. These waves can travel in a vacuum without any problems. Astronauts' transmitters work that way. An astronaut says something to their friend. The sound waves turn into radio waves, reach the other person, and are then converted back into sounds. And this is how we get so-called space sounds. Our planet is actually very loud in that regard. We're sending a huge amount of radio waves into the universe, all radio signals we've ever listened to. It's a pity that they travel only 110 light-years away from us. But I think it's good that we don't hear everything that happens in space. Imagine if sound could easily travel through the universe. We would hear everything, from solar flares to nearby supernovas. Horrifying, right? So maybe we're just lucky. Hey, remember, in space, you can hear ice cream. Chocolate! Vanilla! So, once they explode, stars aren't supposed to come back to life. But some of the stars somehow have survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 4365. It's a partially burnt white dwarf. Now, a white dwarf is a star that has burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. One of those zombie stars used to be a white dwarf, or just left over from an explosion. It gobbled up too much from another star and, surprisingly, managed to explode once again. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1,000,000 years over there because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. In outer space, you'd be strong enough to weld two pieces of metal together with your own hands. Okay, it has nothing to do with your strength. You could just press them together with no effort, and that's it. Oxygen in our atmosphere makes a thin layer on the surface of the metal. It's like a barrier, which is why such a trick is impossible on Earth, but perfectly logical in outer space. If you ever go to space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news? The skin is elastic enough to hold you together, which means you wouldn't explode. Yeah, small comfort, huh? If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around your eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, there's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space. If the fire breaks out in a rocket, you can simply turn off the ventilation system and voila! It can get more complicated if there's intense smoke, sparking, and material melting in conditions of reduced gravity. Regular foam fire extinguishers we use on Earth are useless here because they release foam randomly. Researchers are developing a fire extinguisher that will put out fires by using sound waves. The bigger the sound intensity, the bigger the flame they can put out. But the astronauts might end up deaf if the frequency is too high. A black hole is not like some starving monster that wanders around and has gravity so strong nothing can really escape it. When something comes close to the point of no return, which we also call the event horizon, it disappears. No way back. But quantum physics claims nothing can really destroy data, so it's a true paradox. Stephen Hawking was the one with the idea of how black holes don't really have event horizons. Maybe they have apparent horizons. Those trap things for some time only. After that, the trapped energy will somehow get away, but in a different form. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. It happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it in another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like 4 billion suns, but locally it's far away from us. There are more than 23,000 pieces of so-called space junk bigger than a softball floating above our planet at speeds up to 17,500 miles per hour. Woo! And there are 500,000 pieces in general, some of them the size of a marble. Space waste is generally debris made up of natural particles called meteoroids and artificial particles, like things we make on the Earth. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world, from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space, but they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. There's a lot of it. It may even make 25% of the universe. Dark energy makes the rest of the 70% of the universe. Scientists don't know much about it, but they think dark energy could be behind the increasing expansion of the entire universe, while dark matter slows it down. Dark matter doesn't interact with us in any way that we know of, nor does it interact with itself. If it did, we might be able to find dark matter galaxies, dark matter planets, or such objects. Now, astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bit bored and wanted to check out how things were going in the direction of the cold spot. That's an anomaly in the cosmic microwave background map, or in short, CMB. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. But instead of CMB, They realized there's a giant area way colder than they'd expected. The team started tracking radio signals, but there were no radio sources in that whole volume. That means there are no galaxies or clusters, and since it's so cold, there's no dark matter either, or regular matter, so it really doesn't matter. The giant void is empty, and researchers think it could consist of dark energy. Light can still pass through it. It's not the only void in space, but it's the biggest one we've found. The area around a star is habitable when it's not too cold or too hot for liquid water to exist on the planet surrounding it. Let's say our planet was where Pluto is. It's too far from the Sun, which means our ocean and big parts of its atmosphere would freeze. But if the Earth was in Mercury's place, we'd be too close to the Sun, and the water on our planet would evaporate. Such habitable area is called the Goldilocks zone. So you can see where planets are located and assume if they have a chance for life on their surface. But Europa, one of Jupiter's moons, definitely breaks the rule. It's outside of the Goldilocks zone, but still kept warm. Not from the Sun directly, but Jupiter and its moons that actually pump energy into Europa. Europa changes its shape as it circles around Jupiter. It's similar to tides rising and falling on our planet. Water on the Earth changes its shape as a response to the tidal forces of our moon. When the same happens with a solid object, the object is stressed. That's how you pump energy into that object. It's like you're playing racquetball. You hit the ball around a couple of times before you start playing, like you're warming it up. You kind of distort the ball every time you smack it. The surface of Europa is frozen, but it has cracks in the ice. You can see ridges in the ice where there's a crack. Then those flying chunks shift and refreeze. You'd see a similar thing if you could fly over the Arctic Ocean in the wintertime. There are ice sheets constantly breaking and refreezing. So Europa can't completely freeze. Scientists think there could be an ocean of liquid water under the icy surface. Europa is not the only moon where this is happening. Another of Jupiter's moons, Io, is also warm because of such tidal forces. Io also has volcanoes erupting from within all the time. So it's not only that the Sun warms the space bodies and pumps them with energy. Many experts agree the universe might come to its end about 3 to 22 billion years from now. It's expanding all the time, which means it formed from a compact state. If it has a beginning, it's probably going to have an end as well. Yeah, I won't be around for that. One of the popular theories says the growth will slow down, and gravity will become the powerful force that will make the universe shrink. That will lead to complete chaos. Galaxies, stars, planets, space bodies, they will all move, collide, and, destroy one another. It's like the reverse Big Bang. Huge chaos, but this time, everything collapses. Well, on that cheery note, always stay on the bright side of life.